What I am tracking for this weekend has the potential to be one of the more impactful winter weather events we have seen across the central and eastern United States in several weeks. And I want to walk you through it carefully because this system carries a level of complexity that goes well beyond a straightforward snowstorm. The setup involves a collision between a very cold and entrenched Arctic air mass sitting across the northern tier and an unusually potent surge of Gulf moisture moving northward ahead of a strengthening low-pressure system developing across the southern plains. When those two air masses meet, the result is not a clean snow event. It is a layered, difficult-to-forecast system where the difference between 8 inches of snow and a quarter inch of ice can come down to a temperature gradient of just 1 or 2 degrees over a very short distance. That sharp boundary between snow, freezing rain, sleet, and cold rain is the most critical and most uncertain element of this forecast right now. And I want to be honest with you about where my confidence is high and where it is still building. What I can tell you with certainty is that this system will produce significant impacts across the Midwest, the Ohio Valley, the Central Plains, and the Northeast from Sunday through Tuesday, and that the ice threat across the southern portions of the affected zone is at least as serious as the snow threat further north. Let me start with the large-scale setup because it explains why this system is more complicated than it might initially appear. The Arctic air mass currently in place across the northern and central United States is exceptionally cold and exceptionally deep. Surface temperatures from the northern plains through the Great Lakes and into the Ohio Valley are running 20 to 35 degrees below normal, and that cold air has been in place long enough that it is thoroughly entrenched, meaning it does not erode quickly even when warm air begins pushing northward at the surface ahead of a storm system. At the same time, a ridge of high pressure over the Gulf of Mexico has been pumping abnormally warm and moist air northward across the southern plains and into the lower Mississippi Valley. Oklahoma City reached the upper 70s earlier this week. Memphis was in the mid-60s. That warm, moisture-laden air is now going to run headlong into the Arctic boundary, and that collision is what produces the storm. The low-pressure center will develop across the Texas Panhandle and southwestern Oklahoma Friday night, then track northeastward through Missouri, Illinois, and into the Great Lakes by Sunday night. As it tracks, it will intensify. I'm watching for a central pressure drop that could bring this system into the category of a significant plains cyclone, with strong winds on the backside adding blowing and drifting snow to the already dangerous conditions across Kansas, Nebraska, and Iowa. For the Central Plains, western Kansas, Nebraska, and South Dakota, the storm begins Friday night with snow developing rapidly as the low pulls moisture northward and cold air floods southward behind the deepening system. Snowfall rates in this region could reach 1 to 2 inches per hour at the storm's peak Saturday morning, and I'm currently tracking total accumulations of 8 to 14 inches across western and central Kansas and southern Nebraska, with locally higher amounts possible in areas where the heaviest bands set up. Winds will gust to 40 to 50 miles per hour in this region, which means blowing snow and near zero visibility at times. Travel across western Kansas and Nebraska will be dangerous to impossible Saturday morning, and I want that stated clearly. This is not a storm where you push through if you don't have to be on the road. Moving into the Midwest proper, eastern Kansas, Missouri, Illinois, Indiana, and Iowa, this is where the precipitation type boundary becomes the dominant forecasting challenge. The dividing line between snow to the north and freezing rain to the south is going to be extremely sharp with this system, and that line is going to be moving northward as the storm progresses. My current expectation places the snow-freezing rain boundary roughly along a corridor from Kansas City through St. Louis, Terre Haute, and into central Ohio by Saturday afternoon. North of that line, Minneapolis, Chicago, Indianapolis, Columbus, snow will be the primary precipitation type, and I'm expecting accumulations of 6 to 10 inches across that corridor, with locally higher totals possible in the Chicago metro and across northern Indiana. South of that line, southern Missouri, southern Illinois, and the southern tier of Indiana. The precipitation type picture is much more complex. Freezing rain and sleet are likely across that zone, with ice accumulations of a quarter to half an inch possible in some areas before the precipitation transitions. That ice accumulation, combined with temperatures falling to near zero on the backside of the storm, creates a hazard that persists long after the precipitation ends. The Ohio Valley is the region I am most focused on with this system because it sits directly in the path of the heaviest snow band and also straddles the critical precipitation type boundary on its southern edge. For Columbus, Dayton, and Cincinnati, I'm tracking 7 to 12 inches of snow with this system, arriving Saturday night and continuing through Sunday afternoon. Louisville presents a more difficult forecast. The city sits right on the borderline between heavy snow to the north and significant freezing rain to the south, and a track shift of even 50 miles in either direction changes the outcome substantially. My current best estimate for Louisville is 3 to 6 inches of snow followed by a period of freezing rain. But I want to be direct. That forecast carries higher uncertainty than the numbers further north, and I will be revisiting it as the system comes into closer range. Pittsburgh and Cleveland are both in a favorable position for heavy snow. 8 to 13 inches for Pittsburgh and 7 to 11 inches for Cleveland, with lake enhancement potentially pushing totals higher east of Cleveland into the snowbelt counties of northeastern Ohio and western Pennsylvania, where I would not be surprised to see isolated locations approach 15 to 18 inches when all is said and done. For the Northeast, the storm arrives Sunday morning and continues through Monday. The precipitation type question is somewhat simpler here than in the Ohio Valley, because the Arctic air in place across New England is cold enough to support snow throughout the event for most areas. New York City is currently looking at 5 to 9 inches, with higher totals likely in the suburbs to the north and west where the cold air holds most effectively. Philadelphia is a closer call. I'm thinking 4 to 7 inches, but the southern portion of the metro could see a freezing rain mix on the back edge of the event Sunday night as temperatures crash rapidly. For Boston and eastern Massachusetts, the storm arrives Sunday afternoon and delivers what I currently expect to be 7 to 12 inches of snow through Monday morning. The interior Northeast, upstate New York, Vermont, New Hampshire, and western Massachusetts is positioned for the highest totals in the region, with 10 to 16 inches likely and some isolated locations pushing higher in the favored terrain of the Green Mountains and White Mountains. Snowfall rates across New England at the storm's peak Sunday evening will reach 1 to 3 inches per hour in the heaviest bands, and combined with winds gusting to 30 to 40 miles per hour along the coast, conditions will deteriorate rapidly Sunday afternoon. I want to flag Sunday evening specifically as the window of highest impact for travel across southern New England and the mid-Atlantic. The ice threat across the southern edge of this system deserves its own direct discussion because it is the element of this forecast most likely to produce the longest lasting and most serious infrastructure consequences. From central Tennessee through northern Mississippi, northern Alabama, northern Georgia, and into the western Carolinas, the precipitation through Sunday will be primarily freezing rain rather than snow. The temperature profile in these areas sits just at or just below freezing at the surface, which means liquid precipitation falling from above freezes on contact with roads, power lines, bridges, and tree limbs. I'm currently tracking ice accumulations of 1/4 to 1/2 an inch across much of this zone, with locally higher amounts approaching 3/4 of an inch, possible in the higher terrain of eastern Tennessee and western North Carolina. At those accumulation levels, widespread power outages are expected, tree damage will be significant, and road conditions will be dangerous for an extended period. Utility infrastructure across Tennessee and Mississippi is already compromised from storms earlier this month, and another significant ice event in those areas compounds the recovery timeline in a way that is difficult to overstate. I want to be direct. If you are in the freezing rain zone and you lose power with this event, restoration could take 3 to 5 days given the current state of the grid infrastructure in that region and the temperatures that will follow behind the storm. Behind the system, temperatures will drop sharply Monday into Tuesday across the entire affected zone. Wind chills across the Ohio Valley and Great Lakes will fall to -15 to -30 degrees by Monday morning. Across the South, Tennessee, Alabama, Mississippi, temperatures will drop from the mid-30s during the storm to the teens and single digits by Monday night. That rapid temperature crash combined with wet roads and ice-covered surfaces creates flash freeze conditions that are dangerous even in areas that received little or no precipitation during the event itself. Any liquid water remaining on road surfaces will freeze solid within hours of temperatures dropping below freezing, and that hazard exists from Arkansas and Tennessee all the way through Virginia and Maryland. Looking ahead to early March, the pattern transition that follows this weekend's storm is the element of this forecast that I think will define the weather story for the next several weeks. As the Arctic air mass retreats northward and a more amplified ridge develops over the western United States, the door opens for warm, moist air from the Gulf of Mexico to surge rapidly northward across the southern and central plains. That surge of warmth and moisture, colliding with the remnant cold air still in place across the Ohio Valley and the Mid-Atlantic, creates the classic ingredients for organized severe weather. The wind shear profiles I'm seeing in the medium range guidance for the first 2 weeks of March are significant. We are talking about the kind of directional and speed shear that supports supercell thunderstorm development and, under the right conditions, tornadoes. I am not issuing a tornado outlook today. The timing and placement of individual severe weather events in early March carry too much uncertainty at this range. What I can tell you is that the first 2 weeks of March have a high probability of being active for severe weather across the southern plains, the Mississippi Valley, and the southeast, and that the transition from this weekend's winter storm to a severe weather pattern could happen faster than people expect. The atmosphere does not take long to flip when the forcing is this strong. I want to thank you for staying with this forecast through a genuinely complex and multi-layered weather pattern. The weekend storm requires close attention right up to landfall because of the precipitation type uncertainty. The early March severe weather signal deserves monitoring as we get closer, and the period in between carries its own hazards in the form of extreme cold and flash freeze conditions. I will continue updating as confidence builds on each element of this forecast. Stay aware of conditions in your area. Make sure you have a plan for both the winter storm impacts this weekend and the potential for severe weather as we move into March. And I will have more information for you as this pattern continues to evolve.